I'm Paul Carlton. I work for Hewlett-Packard in a Nova engineering team. I'm going to talk to you about migration, live migration, evacuation, cold migration as we call it. So moving instances from node to node. I mean, when I first started with this, I thought, well, why would you want to do that? But when you think about it, it's essential. A couple of use cases. Host maintenance. So you've got a host that's looking dodgy, it's got disk errors, it's got all sorts of problems potentially. You need to move your instances off there. You've got your rolling updates. So for example, you know, you're going to want to reboot your servers occasionally as you put in security updates or rolling software patches. And every few months you may want to do that, so you need to reboot every hypervisor in the estate. So you need to move all the instances as you do that. So that's a orchestration challenge in itself. And the other one is resource optimization, basically defragmentation, as you may be aware. With OpenStack, you can either stack or you can spread. So you can set up a scheduler to spread things evenly or stack them on nodes. But whatever you do, you're going to end up with instance deletion and creation with some defragmentation, and you want to move things to make more space on some servers, or move things to stack them all up on a server. The other thing we've met is, as well as a use case, is the case of people wanting to move instances to particular parts of the data center. Wasn't immediately obvious to me, but somebody said, well, what we do is we stack, and then we make sure we move things to a particular rack, and then we can effectively turn off the air conditioning in other parts of the data center if it's not fully utilized. And apparently this makes some significant difference in the cost of running a data center. And recovery from failure of a computer. So if a computer goes down, bang, it's gone, and you can't get it back up again. Clearly you can't get the data off that potentially. There are a number of the different failure scenarios here are legion, from it's dead and it's never coming back and sorry about your data, to we can get it back up and maybe move some data manually or whatever. But either way, evacuate is a maybe quite often misunderstood and sometimes little known operation in Nova. Basically what evacuate will do is it will recreate those instances somewhere else. Clearly you don't get your data, your ephemeral data, but you can get all your setup, all your IP addresses and all of your floating IPs, everything is set up just as it was before. And of course if you're using shared storage, you effectively could be getting your instance back as was. So if you, for example, if you booted from a Cinder volume, you're probably not, your loss is, it may well be 0. So that's, those are the basic options. There's the live migration, which will move an instance while it's running. There's evacuate, which for rebuilding something somewhere else. And there's cold migration, or migration, which basically is used in two models. One is for resize. A customer can use it when they want to resize their instance. So if you've got a flavor that is 4 gig memory and you want 8 gig memory, more CPUs, basically you resize it, which basically means we tell the scheduler, well, actually what I want is an instance of this size, find somewhere you can put it, and then it moves the data, deletes your old instance and reboots the new one, and you're good to go. So those are the use cases. I'm going to talk about what we know best, which is, as HPE, we know about the libvirt scenario, libvirt KVM. Live migration works on Hyper-V and VMware and Zen API as well, to different extents. So I'm going to talk about how it works, what the limitations are, and what we're doing to improve that. So let's first of all just make sure we're all clear on what we're talking about. A VM running on a host, it's got connection potentially to an iSCSI device, an external disk like Cinder. It could have a local disk not shown on the diagram, and Nova will have set up Nova will have set up the networking so that it's got a connection to Neutron, and then Neutron will set up the port so that it's got connection to the outside world. So now we've got ourselves an instance which is being managed by libvirt, nova and neutron. And so now we talk about live migration, which is the more challenging of the migration scenarios. The first thing we do is we select a destination host. Now, in the past, what you had to do was tell it where you wanted to go. And that was tricky because you had to know that the target server you chose was good for this instance. That's become increasingly difficult with things like PCI pass-through and SRIOV and NUMA topologies, etc. You can get it wrong, and different types of, if you've got an estate that has lots of different types of CPUs, you can get all sorts of trouble. More recently, in a couple of releases ago, they added the ability to let the scheduler choose where to put the instance, just like it was a brand new instance. And I'd strongly recommend using that approach. I'll come to some of the shortcomings with that in a minute at the end. But basically, the scheduler will choose a destination host for you. And so the host is chosen. Then it does what it calls pre-live migration. And in the pre-live migration stage, what it will do is it'll set up all of the internal networking necessary and the connections to any Cinder devices, iSCSI devices, etc. that you're using, ready to go. This is what Nova does. Now it hands over to libvirt_QEMU and gets it to do the copy. So now libvirt has started the instance on the target in a pause state, as we would call it in Nova, suspended in Versh parlance, and QEMU, which is actually the process running the instance, starts copying the data across. And that'll happen, basically how it does it is it copies the data, copies the disks first, if you've got any ephemeral disks, and then it'll copy the memory, and then it'll redo that until such time as it's caught up with itself. So remember, you're still dirtying memory here and disk on the source because the source is still being used, and it's copying it as it's going, and it has to repeatedly copy the same blocks until it catches up, and then it gets to the point where it can switch over because it's only got a tiny bit of copy, and then it does the next stage, which is it does its final copy, and now it can bring this one up and running, and we can plug the network. So that at this point where the final copy occurs, all the stuff is set up here, and then when we do the switchover, then we ask Nova asks Neutron to plug the port to this host instead of that host. Yeah. And if you're using, depending on what Neutron provider you're using, that can be a no-op to something significant. If you're using DVR, for example, with multiple routers, it has to switch it to a different router. If you're using other models, we found, and I'll come to this in a minute, we found cases where it hardly even notices that it's moved. Even before you've moved the port, it's still the new one's working because of ARPing, etc. It can detect where the IP address is now. But in the case of DVR, you need to move that, and that's been something we've had a struggle with. So let's talk about some of the challenges with this. Well, there's a number of challenges which I'll talk about. Hypervisor doesn't know what type of disks it's got, so the hypervisor being libvirt_QEMU doesn't know whether the disks are shared or not shared, and unless you tell it. That was a problem in the past. Migration may never end. Now, I think this is still a problem, and I think our experience of this has been difficult. I used to work I still do work for HP. When HP used to run a public cloud, we had a significant public cloud offering at one time, and I was responsible for managing that and migrating instances, etc. And one of the things we found was, and we were running Icehouse, so it's a little while ago. One of the things we found was that it was a disaster, live migration. It didn't work half the time. Well, we had a 15% failure rate. 15% failure rate might not sound that bad, but when failure means the instance going to a halted state rather than migrating, that's bad because the customer was told their application wouldn't go down, and it did. And also the operational challenge of dealing when you're migrating, tens of thousands of instances over a period of days and weeks from one node to another. If you get a 15% failure rate, you need a number of operations people to deal manually with those failures, and that actually stopped us dead in our tracks before customer services said, whoa, we get some complaints. The other issue we had was, even if it worked, we were finding that customers were phoning up and complaining and saying, the performance of my instance has gone downhill. Well, we're migrating it, because they can see we're migrating it. It shows when you do a Nova show that it's migrating. And when we got our systems people to look into this, one of the things we found was it wasn't to do with the networking or anything like that, it was disk I/O. When you're doing the migration, especially if the source instance is using ephemeral data, local disk, and it's got a lot of local disk, the amount of disk I/O as it's reading the source disk and writing to the target disk can be quite considerable. And that was having an impact on other instances on the same node as well as that instance, because that QEMU process had a certain amount of bandwidth in terms of disk I/O to play with, and it was now using 90% of it to copy the disk to a target. So the performance one I don't think is solved yet, but it may never end. But we've dealt with that in a number of ways. The migration traffic can impact the network. So if you've got a network and the network is shared with neutron traffic, and suddenly you start putting across it copying of entire instances, suddenly you start to see a problem. So we looked at that as well. And the new resource types. So as we added things like PCI, PT and SRIOV, there are some challenges in live migration that are not yet solved. The other challenge is the security one. The data in flight is not particularly secure in a QEMU model, and the cold migration currently implemented using rsync and STP, which uses passwordless SSH using SSH keys, and not all customers are comfortable with that. So let's now talk a little bit about the sort of things that we've been doing, and when I say we, what I mean is the community, ourselves, Rackspace, Mirantis, a number of individuals from those, Red Hat, from those companies, in order to try and address some of these problems. Well, so there's this specific problem where if you've got an instance that has ephemeral storage, local disk, and also volumes in Cinder. There was a time when libvirt just all assumed that they were all local disks and started copying them. So it'd start copying a Cinder volume. So what you'd do is you'd attach to the Cinder volume at the source, and you'd attach it to it at the target. The target is paused, so it's not touching the disk. But now you're talking to this same Cinder volume, effectively you've got a connection, and then libvirt would start copying the data. So it'd be sucking the data off the Cinder volume, across the link, and then onto the Cinder volume at the target. So it's rewriting itself. Yeah? That was obviously both suboptimal in terms of resource usage, and also it could actually corrupt the volume. So that wasn't great. And obviously if you didn't copy a disk and it's a local disk, then you haven't got your half potato at the other end. So you kind of need to do it. So what they did was they put something into libvirt. It went into 1.2.17, which basically meant that the caller of libvirt could say, for each disk I'm attached to, this is what it is. This is local. This shouldn't be copied, or because it's not local. So so if you're using shared storage or you're using Cinder volumes, you can say omit that volume. If you've got a local disk, you could say copy that. So we were able to deal with problems with config drives, because we could say don't copy them because it's read only, etc. Local storage we'd copy, but external storage we wouldn't. So we put that in so that we can do selective disk choice in disk copying, and that went into Mataka. So that addressed one problem. A more tricky problem is this idea of you may never catch up. So if you're doing, libvirt is doing QEMU, is doing the migration, and at the same time you're hammering away at the instance part of the application, you've got to be able to keep pace with the rate at which the instance is dirtying the memory and disk and copy the data. So we talked about this in the community, and all sorts of suggestions were bandied around about APIs and all this sort of thing to deal with this. We also talked about a trade-off, because live migration is an operations function. Operations want to migrate the instance for one of the many reasons I've discussed. But the user doesn't. The user just wants to use their application running in their VM, which may be supporting their business. And they really don't want any particular interruption in their service. So you've got a trade-off there. And how hard you work, how much you impact that instance in order to do the migration is a decision that you need to make based on how important that instance is to you, the cloud provider, and your customer who's using that instance, your user, or how desperate you are to move it off. The sort of things that might influence that decision. If it's on an instance that you're doing on a compute node and you're just doing a defrag, well, maybe it doesn't matter that much if you can't move it. If that compute node is about to fail because you're getting warnings in your monitoring system saying it's got critical disk errors and it's about to go, then clearly it's a bit more important it goes. If the instance is, and we use the term cattle or pets and pandas, if the instance is just a cloud instance that is backed up by another cloud instance, and if it died suddenly, the customer's application would auto rebalance and would be fine, that's great. But if it's something that's running an application that is very important to the customer and is a singleton, then clearly we can't influence it. We talked about this, and we talked about how we might represent this thing. And to be honest with you, we never came to a conclusion on this, because I think the community was uncomfortable with categorizing instances in that way, and dealing with, and trying to put an API in place to support that. So what we eventually went for in the end was an automated approach. So we said, look, live migration should be invisible, it should happen, and it shouldn't be an operator challenge, going back to my previous comment about our public cloud experience. It shouldn't fail, and it shouldn't need to have an operator sitting there nursing it through. It should nurse itself through. So what we said was, what we need is autocomplete. What we need is a number of features that can be used heuristically in order to get the migration to reach its conclusion. And so what we first of all did in the Mataka release was we added a couple of APIs. We added force complete, and what that did in the Mataka release was it just suspended the instance. And again, this maybe goes back on my previous comment, but we felt that if the operator saw that an instance wasn't completing, they could do a suspend on it effectively, which is not like Nova suspend, because the difference between Nova and suspend on an instance. If you Nova suspend an instance, it stays suspended when the migration's finished. This force complete would effectively suspend it on the source, but once it moved to the target, it would automatically be resumed and it would continue running. So if you know that the customer is the user of that instance could be comfortable with that, or you realise you just have to get it done and therefore they're going to have to be comfortable with it, that was one option. The other thing we did was cancel, because there are cases where you look at a migration and it's not completing. You may have the customer bleating at you saying, look, my instance is being impacted by the performance of the workload here, and I'm not don't want this to happen. In the past, the only way to cancel it was to go into Versh and do an abort on the job that's running. So we added an API call for the administrator so that they could cancel it. The other thing we did was we added configuration parameters in the Nova conf that allowed you to configure what period of time you'd accept as the cutover. So yeah, when we talk about live migration, it's not live. It's live as in you're still up while it's running, but there is a period while we're doing the actual final copy and then a cutover where you're going to be down. Yeah? And that's going to be a number of milliseconds, or seconds or whatever. Yeah? And it's configurable. Basically libvirt, you can tell libvirt via these configuration parameters in Nova that Nova communicates to libvirt, and you can tell it that you're prepared to accept up to 500 milliseconds or 5 seconds or whatever it is as that cutover period. So what you do is you set 3 parameters. You set the minimum, basically, we'll start with a 250 millisecond delay and try and do the cutover. If we can't copy everything in that period, and then we'll just carry back on again. We'll go up to, say, 5 seconds, and we'll do it in chunks of 50 milliseconds or whatever. Yeah. So we can configure these parameters so that you can give it more chance of cutting over. Now in Newton, what we've made is some additional changes. In the more recent versions of QEMU and libvirt, there's a couple of new options: post-copy and auto-converge. Now auto-converge has been around for longer. What auto-converge does, if you turn it on, it says, what I'm going to do is, as I reach the point where I've copied most of the data, but I can't get over that final hurdle, what I'm going to do is I'm effectively going to reduce the CPU bandwidth available to the instance, to the user, to the source instance, in steps until it gets down to potentially even 0. Yeah, where effectively it's suspended, and that will hopefully give me an opportunity to copy the data across. Because now, of course, because the CPU is being reduced, the client application, the application running in the instance, can't do as much work, and so we can't dirty as many pages and do as much disk I/O. Tests by some of the libvirt guys have shown that that is actually not a particularly effective solution. It tends to only work when you get down to 0, and so it effectively is a bit like force complete, but it's just an automated version of force complete. So it is a solution, and it's been around for a while, but it wasn't our favourite. More recently, they've added something called post-copy. Now, what we're doing when we're copying, of course, is we're running on the source and we're copying to the target. Until we get the target ready, we can't switch over. What this does is post-copy can say, there's a point at which I think I've done the first pass of the memory, and I'm really not making any progress. Yeah? And the libvirt can detect that, or Nova can detect that by virtue of looking at the monitoring that it does of libvirt, and it can say, I'm not making progress. What I'm going to do is I'm going to tell libvirt to switch to post-copy mode. What that does is it pauses the source instance, activates the target instance, and now you're running on the target. But the target is missing some of your data. Some of your memory pages have not yet been copied. But QEMU is clever enough to say, every time you try and access in your application a page that I don't have, I'm going to generate a page fault, and I'm going to go and get it from the source. So now you've still got a performance implication, you've still got to copy those pages, but now effectively you've got the application kind of on your side, because it's not dirtying the pages at the source anymore, so you stand more chance of completing. And this we felt was quite a good option. So we added this facility. This was added in libvirt, and then we added this facility in Nova to effectively make this happen heuristically. So the way it does it in Newton is it says, if I haven't made a certain amount of progress in a certain period of time, I'm going to switch to post-copy, assuming you turn post-copy on. Both post-copy and auto-converge can be enabled or disabled in the Nova conf. So basically, if you don't enable those features, and they're off by default, nothing will change when you go to Newton when it comes out. What will happen is if you turn them on, one or both of them, then those will be considered as options. If you turn auto-converge on, it will auto-converge. If you turn post-copy on, it will disregard auto-converge and it will just do post-copy. Yeah? If it decides heuristically that it's not making progress and that post-copy will help. There's another option, and that is force complete, which I mentioned earlier. If you've turned post-copy on, force complete will no longer suspend the instance, do a pause on it effectively in verse. What it'll do is it'll force the switch to post copy, because now we've got post copy in our arsenal. We feel that's better than suspend, because at least you're getting some performance out of the instance, even if you may be having heavy page faulting. So that's some of the stuff we've added. Now,
on the post copy, you know when you finish? You know when you can turn the original one off?
Well, that's an interesting thing, yes. You absolutely do. libvirt does. libvirt and QEMU know. Because QEMU is doing the hard work. He's copying the data. And when he knows he's still copying...
Oh, he's still carrying on copying? He's
still carrying on copying. He's not doing it totally on demand. No. He knows in the source what he hasn't copied, and he's still copying
That's where it stopped, right.
proactively, yes. He's also responding reactively to page faults and copying those pages as a priority because the application needs them. When he finishes, he will then do the normal stuff of telling libvirt that he's finished. libvirt will tell Nova, and Nova will do the post-live migration steps of switching the network across. Yeah? Some of you might have spotted the bug with this. When we switch to post copy, we switch the destination to active. But nobody told Neutron. So the port is still on the source, which is now paused, because that's what you do when you switch to post copy. You pause the source and you activate the target. Yeah? You make it running. So this bug actually got through testing, because in testing they were using a Neutron configuration that had a single router. And so the ARPing coming out of the target was basically dealing with the problem. Once somebody tried this on a DVR system where you've got multiple routers, suddenly they were saying, and also with sort of workloads that meant that post-copy phase wasn't milliseconds, it was tens of seconds or even longer. Suddenly they said, hang on, what's happened to my instance? It's running, but I can't get to it. So we're fixing that bug. Somebody is working on, basically Nova knows when it's switched, because Nova has to tell it. There is no heuristic in libvirt to switch automatically to post copy. Basically the Nova monitoring thread is controlling that, and it tells it to switch to post copy. What it should also be doing at that stage is telling Neutron to switch the network. QED. Seems simple when you think about it, but you know.
Is it still concerned about the disk?
Sorry?
Is it not still concerned about the disk?
It only works for memory, so the disk has to be copied in its entirety.
And that's rolling from the old active to the new active, whilst it's now running.
So the disk, it assumes the disk data is copied. Now this is an interesting question. I've not got the bottom of this. As I understand it, post copy is only related to memory. Yeah? So it basically will copy the memory pages. The disk pages, what libQEMU does is it copies the disk first, and then once it's done one pass of the disk, it'll start copying the memory. And it'll continue copying the disk as the disk pages are dirtied. That is a good question, and it may well be another bug lurking there that...
Sorry, I had a quick question.
Yeah.
Presumably when it switches to post-copy mode, it has to sync across the dirty state of the memory at least to the new active.
No.
Well, how do you trigger a page fault for a page that is present but not...
Well, QEMU, so basically when you're thinking about your virtual machine in a KVM, libvirt, QEMU model, what you're actually running is a QEMU process, which is emulating the underlying... And that QEMU process is hosting your OS. So you've got a Linux OS potentially running in a thin QEMU wrapper. So effectively, if you look at it on the hypervisor, what you're running is QEMU. Yeah? The QEMU process knows, on the target, knows what pages he has been copied to him, and what pages he hasn't had copied to him. Yeah? So he doesn't know what's happening on the source, but he does know of these 500 pages, to give it a silly example, I've got 450 of them, but there's another 50, these 50 I haven't got. So the moment you tell libvirt on the source, switch to post copy, he tells QEMU, and QEMU tells his target, you're active now, so up comes the target, he's running, the application in there wakes up and away he goes, and the first thing he does is accesses one of those 50 pages. QEMU knows he hasn't got that page.
I'm more worried about the one of the 450 that has been changed on the source before you did the switch?
No. So maybe, let me try and explain that again. Assuming you've got 500 pages and you've copied 450 of them and you know they haven't been dirtied at the source since...
How do you know that?
Well, the two QEMU processes know that. The QEMU on the source knows what he's copied clean copies of. The moment you touch a page on the source, that goes back into the 50 categories, so out of the 450.
That's what
Yeah. So he knows that, so he's good to go. You made a good point about the disk. I know that QEMU copies the disk first, and then I know it copies the memory pages, because I'll come to that in a minute. It's a bug relating to that. But of course, when you're copying the memory, it's still dirtying disk, so you have to continue copying dirty disk pages. I hope and believe that at the point where it switches to post-copy, what it does is it works out how many disk pages have been dirtied since it last are still dirty, yeah, and it copies those, and hopefully there'll be a handful of pages, and it copies all of those to the target, and then it activates the target. If it doesn't do that, we need to speak to the QEMU libvirt guys and get them to fix that.
And all the memory caching associated with
No, not the memory, just the disk. I know what you're talking about. You're talking about the disk pages that are in memory. Well, they are just seen as memory. So, effectively, if I access my disk cache, it's in a memory page, and either that memory page is there or it isn't. If it's there, then I get it. If it isn't, then QEMU goes and gets it from the source and brings it across.
Memory has to be non-representative of the disk.
Well, it has to be representative of the disk. I mean,
not if it's not flowed across. If the disk hasn't flowed across, then the memory...
That's what I've said. I hope and believe that what happens is, at the moment when libvirt tells QEMU we're going to go switch to post-copy, QEMU on the source says, right, I've copied 99% of the disk, I've got this 1% of the disk that hasn't been copied. I'm now going to copy all those pages to the target. So the target disk, local disk, is completely up to date. Yeah? And then I'm going to execute the suspending of this instance, pausing, and the activating of the target instance, and then I'm going to carry on copying memory pages. Now, of course, I'm not getting any more dirtying on the source, but I've got these page faults on the target. If one of those pages that haven't been copied from the source memory to the target memory is a disk cache page, then clearly when I access that page to do another write to disk, then I will, before that write occurs, I will copy that page of memory from the source to the target, and then I'll carry on, and it will be writing it through to disk at its own merry time, and that'll be fine.
And you're not continuing to copy the disk?
No.
And you think that's not a bug?
I don't think that's a bug. I think they've got that right. I'll ask, but I'm pretty sure that they'll have thought of that.
Okay.
Just like we thought of the neutron thing. Yeah, no, I'm sure they've got that right.
Good-o.
Migration traffic may affect. So in the old bad old days, pre-Mataka, the network used for migration was the same network used for neutron traffic. So now your network between these two compute nodes was being saturated potentially by live migration traffic. We've added the facility to split that out effectively and to configure a separate network for migration traffic, so it doesn't affect the neutron traffic. This has been fixed. Basically, there was a time it's been fixed in Newton, so it's not really fixed yet, I guess. There was a time when what we did in the post-migration step was we said, we've now completed the migration, we'll tell Neutron to switch the network. And Neutron would take several seconds to do that. By the time we sent it the API, it talked to all the routers and everything and got everything done. And so there would be a hiccup at the target when you're switching over. We've fixed that now because what we do is in pre-live migration, we get it to do 90% of that work so that when we tell it at the end to switch the network, it's just got to go like that. So they fixed that in Newton. This isn't fixed. If you're live migrating and you've got NUMA pinning, SRIOV, PCIT, then all bets are off. It's aspirational to fix that, but it won't happen in Newton. there are problems with the migration of instances that are using Luma pinning and PCI devices, which we need to address. Yeah, that's right. Security of data in flight. So QEMU uses MBD to do its copying, a network block device, which is very quick, but not particularly secure. It doesn't use any SSL over the network. libvirt uses TLS, but it's slow. And also libvirt doesn't refresh its certificates without stopping the libvirt process. So if you want to refresh certificates, you have to stop the libvirt process. There's work going on. One of the things you can do is you can tunnel QEMU through the libvirt TLS thing, but there's work ongoing to improve the libvirt TLS connection, so that you can update your certificates and it will effectively generate or use those new certificates on the fly. So that'll improve the security of that tunnel, and QEMU can use that as a tunnel using NDB over TLS.
Quick question.
Yep.
Do you know what version of TLS it uses?
I don't. No, sorry. I think it used. Yeah. No, I don't know. I won't try and guess that one. So a little bit about cold migration and security. Cold migration, as I said earlier, uses SSH. Basically, it's SCP rsync, and it uses SSH keys to copy the data. A lot of customers have said, we don't really want that. Yeah, that's not, SSH keys, between all our compute nodes is a potential, security problem for us. We've got work in plan to use something called libvirt storage pools. Now, libvirt has a thing called storage pools and storage volumes. So you create a storage pool, and in there you create volumes. So you configure effectively the ephemeral disks that the instance is using as libvirt storage volumes. And the advantage of that is that you can copy the data then. Libvirt can copy the data to a target libvirt, as it were, using its TLS link, etc. And it can do it between one storage volume and a storage volume on the target. So it's all secure and it's great. It's horrendously slow, and we're dealing with that. And it's not implemented in Nova. Nova doesn't use storage volumes, but we're going to implement that so that effectively people can do cold migration of instances that are stopped to a target node without having to have the SSH keys on all of the compute nodes, so that with the potential security gap that might provide for them. Future work. So we're going to support rescued instances. So at the moment, live migration can support instances in almost every state except for error and stopped, and rescued. We're going to add rescued to it. We did that work in Newton, but didn't make the cut, so we're going to resubmit it in Okata. Fixed monitoring timeout. So this is an interesting thing. There's a monitoring thread that was added that monitors the live migration. It talks to libvirt and it gets the libvirt counters so it can see how it's progressing. And that reports that in the log repeatedly, and you can see that data by doing a list migrations, and you can see the progress of the migration. However, it starts monitoring it immediately. But the first thing the QEMU does is copies the data from the ephemeral disk to the target. Now, again, this is developers and their test case. If that's a Syros instance that you've never used, that data copy is seconds or sub-second. Yeah? If it's a large instance with a terabyte of data and it's being used a lot, that can take minutes or hours. Yeah? And what happens, of course, is the monitoring thread says, I'm going to monitor how much progress you're making on copying the memory. And if after a configurable period, 150 seconds by default, you've made no progress at all, I'm going to abort this migration because it's clearly going nowhere. Well, what we've done is 150 seconds worth of copying disk data. And of course, after 150 seconds, if you haven't got your disk data copied, it kicks you into touch. Workaround at the moment, of course, is to set that timeout to a much higher value. We're fixing that in the next release. So it'll copy, I'm assuming we'll be monitoring the disk data, and then we'll start monitoring the data to the memory. Lots of refactoring needed here. There's another thing, this one was discussed at the mid-cycle in Portland, and it didn't really get much leverage. There was some disagreement among the developers about it, but I think it's an important feature. At the moment, it's a binary thing. You either use force host, in which case you tell it, I want you to migrate him from where he is to here, yeah? In which case, the scheduler doesn't get consulted at all. You're going there. And if it turns out that that's running on a different CPU, or it doesn't have the right NUMA config, doesn't have enough disk space or memory or whatever, or CPUs, then tough. We're putting it there. Yeah? And that's great for as an operator tool, for an operator who knows what they're doing and knows that this is going to be good. But in the case where you've got an orchestration tool that is, say, doing rolling migrates, now, the scheduler looks at, if you use the force, then you've got required to know a lot about what the scheduler would know in order to make that decision correctly. If you use the scheduler will say, I'm going to put it anywhere that is appropriate. Yeah? So basically it'll go through all its filters if you're using the filter scheduler, and it'll go through the host aggregate filter and all the different NUMA topology and disk and memory filters, and it'll get it right. It'll pick a good node. However, picture the scenario where you're doing a rolling migrate, rolling update, sorry. You're going to reboot every compute node in your estate, and you're going to migrate instances. There's two ways of approaching that problem as I see it. One is to do host to host. So if you know that two hosts are identical in their configuration, you can move all the instances from host A to host B, then reboot host A, and then you can move all the instances from host C to host A, and reboot host C, and rolling in that way. The problem with that is you need to have hosts that are absolutely identical to do that. So you have to have pools of hosts that are identical and can be done. And that may well be viable. Also, you need to have empty hosts to start off with. You need to have a pool of hosts that are got nothing on, so you can move all the instances from A to B. So that's wasting resources. And the third problem is when you live migrate, and you migrate half a dozen instances off host A to host B, but the seventh one just won't go because it's an error state, or because it's busy and it just can't move. Now your whole house of cards is collapsed because you've migrated these to from host A to host B, but host A isn't ready to receive the host C instances because it's not empty. It's got this instance on it, so there might not be room for everything on host C. So that approach doesn't really work unless you can be guaranteed that you'll always move the instances, and you can guarantee that the hosts are identical. The other approach is to let the scheduler do it. So you basically migrate your half a dozen instances off a host to wherever the scheduler chooses to put them. And that's great. But if you're halfway through your rolling migrate and half of your hosts have been rebooted onto the new OS kernel, the new clib library, whatever it was that you put in to fix, say, a security bug, yeah, and half of them aren't, the scheduler doesn't know that. It just chooses a host that is appropriate for this particular instance. And that host may well have been a rebooted host, or it may not be a rebooted host. So effectively, you could end up migrating an instance to another host where it gets migrated again and then again. And so in the worst case, you could be migrating a particular customer's instance for 5 or 6 times during the rebooting of a couple of thousand compute nodes. So the orchestration tool, on the other hand...
Doesn't the scheduler know the version?
The scheduler doesn't know any, unless you add a filter that does that, and there is no such one, it doesn't know anything about the host other than it knows about memory, it knows about disk, it knows about the NUMA topology, There's no filter unless I'm missing something. Host capabilities it knows about, but it doesn't know what version of the OS it's running. It can't say you're running kernel 2.4.1 and I'm on 2.4.0. Yeah, it's not there. Now there was a talk with this extensible resource handler a few releases ago of adding just that, to basically having an extensible resource handler so that you could plug in your own implementation specific tool on the compute host, so you could put some Python code there that it would call, and that would return some sort of results that you could use to do just that sort of decision. This host is a rebooted host, it should be weighted, yeah, because this is really not a scheduler binary choice, it's a weighting. For example, what we wanted to do was have a weighting that said, you know what, you're going to get your pool, your window of hosts that you could migrate it to, but I want you to weight towards ones that have been rebooted, not ones that haven't been rebooted. If you can't find one that's been rebooted, say it late, as you won't find in the early stages of this process, go for it. But that didn't get past the community. We didn't do that. So now it's up to the orchestration tool, which can find this out, because the orchestration tool is kind of the one that's doing migrate everything off that, reboot it, now migrate everything off that one and reboot it. So the migration tool will know what he's rebooted. So one of the suggestions with this in mind was that instead of having the binary force host or scheduler, that we could send the live migration API a list of hosts that it should choose from. So basically you could send it the 5,000, if you had 500 hosts, you could send it the 15 that have been migrated, have been rebooted, or 140 that have been rebooted, depending where you are in your cycle. And you say, let the scheduler choose, but let them choose from these, and that wasn't widely accepted. I mean, in the old days, we'd have probably just added a new filter for this. You could easily add a filter that does this, but the community's not moving away, moving away from custom filters now. And that may be a better way of achieving this, is to propose a filter that would do that sort of thing. But the trouble then is, how do you implement that in a way that is good for everybody's cloud? So anyway, yep, we're done. Okay.
Well, as you wrap up.
Okay. That's about it, really. I've got one more slide, I think. Yes, that's the Okata specs for the cold migration switch to volume. Questions? We've had some questions as we went along, so any?
Yeah, I just wondered for the SSH cold migration, whether you looked at running SSH in its certificate authority mode instead of private public keys, shared machines.
It could do, yes, but that would be a configuration choice, and I mean, you'd have to configure that, and that may be more secure. And some people take the view, I mean, in our cloud offering, HPEs, we turn it off by default, but we can turn it on if people want to. Different people have different views about that, and some people might say, well, actually, it's not a problem. You know what? Because we can copy it just as we've got other mitigating factors, but everybody's different in that respect. Okay.
Thank you.
Thank you.